Oh Lord, I can't do this.
Atoms make up everything. They're all around us and we interact with them every day. In the beginning of time, people didn't know a lot about atoms. It has taken thousands of years to get to where we are now in our understanding of atoms. And we're not even done yet. There have been 9 major influential figures which we'll examine in this video. Watch on to see how the atom has been studied and researched to get to our understanding today. Democritus, a Greek philosopher, was alive during the time of the ancient Greeks. In about 400 BC, he suggested the idea of atoms by saying that all matter was made up of tiny, discrete particles. Also, he said that the properties of these particles correlated with the properties of the matter itself. He believed that these particles were not divisible. Can you believe he was the first recorded person to ever suggest the idea of an atom? No!
Fast forward 500 years. In the 17th century, an amazing man named John Dalton, an English chemist, physicist, and meteorologist, supported that the atom was a fundamental chemical element. In 1803, he confirmed this and then wrote his own atomic theory. There are 4 parts. First, all matter is made of atoms, and said atoms are indivisible and indestructible. Second, all atoms of an element are identical in mass and properties. Third, compounds are formed by a combination of 2 or more atoms. And last but not least, a chemical reaction is a rearrangement of atoms. On top of his atomic theory, he formed the first atomic model. It was just a solid sphere. Eugen Goldstein, also known as E. Goldstein, was a German physicist. In 1886, he was the first person to discover canal rays, also known as positive rays. He found this out because positive rays travel in the opposite direction of the negative rays. This led him to discover the positive nature of the proton because cathode rays were not the only thing traveling in the opposite direction of the electrons. In 1897, British physicist J.J. Thomson discovered a ratio of the mass of a particle to its electric charge. He subsequently discovered that the charge of an electron is negative. He found this out through an experiment called the cathode ray experiment. He measured how rays were bent by magnetic fields and how much energy they carried. Thomson also came up with the plum pudding model of the atom, affectionately called the chocolate chip cookie model by Mrs. Adams. This model depicted the atom as being random. There was no order to where electrons and protons floated. Also, he said that the space in which they were found was all positively charged. In 1909, Robert Millikan, an American physicist, conducted an experiment with dropping oil. This experiment was called the oil drop experiment. In this experiment, he gave a tiny drop of oil a charge and then tested to see how strong a magnetic field had to be in order to keep the drop of oil from falling. All of this led to him determining the charge and size of a single electron. Ernest Rutherford was a British physicist. He is most well known for his gold foil experiment in 1911. He used particles as atomic bullets by putting the atoms in a piece of super thin gold foil. This made it clear that the nucleus of an atom was very dense, very small, and positively charged. Rutherford assumed that electrons were located outside the nucleus. He also came up with another nuclear model of the atom based on this experiment. However, he still believed that electrons floated randomly around the nucleus, which we later found out was not true. In 1922, Danish physicist Niels Bohr developed an explanation of atomic structure that took into account similar things about the periodic table of elements. He built an atomic model based on his explanation, which is called the planetary model. It has the negatively charged electrons orbiting around the positively charged nucleus in an organized manner, sort of like how planets orbit the sun. An Austrian physicist by the name of Erwin Schrödinger viewed electrons as continuous clouds. In 1930, he introduced wave mechanics in a more mathematical model of the atom. Schrödinger took Bohr's idea about the path of electrons and altered it slightly. Using math, he was able to prove that there was no way to tell exactly where electrons were or what the orbit was. Only a relative location could be given. In looking at his model, The more dense parts of the cloud indicate areas where electrons are more likely to be found. On the contrary, electrons are not as likely to be found in the less dense areas of the cloud.
In 1932, James Chadwick, a British physicist, used the same alpha particles as Rutherford, and with these particles he discovered neutrons. For years after Rutherford discovered the proton, scientists had looked into the idea of there being another particle in the nucleus along with it. This idea originated when it was discovered that the atomic number of an element was not equal to its atomic mass. There had to be something else in the nucleus. Chadwick conducted a series of experiments using an alternative method of particle radiation. He found out that there was in fact another particle found in the nucleus with almost the same mass as a proton. The mass of a neutron is actually 0.1% more than a proton. But who's counting? The neutron also had no electrical charge, unlike the proton who had a positive charge. Hence, the neutron was born. Today, there is still more to discover about the atom. The world is waiting for new bright minds to come and conduct experiments that reveal new innovative things about the atom. 7 out of 9 of these brilliant men have won the Nobel Prize, including Rutherford, Thomson, Dalton, Bohr, Schrödinger, Millikan, and Chadwick. Goldstein was nominated 3 times, and poor Democritus, there wasn't even a Nobel Peace Prize during his lifetime.
3, 2, 1.
Got a blast!
To the stars, you'll buy candy bars. Rise a kid with a knack for invention. With a superpowered mind, a mechanical king.